This video is going to be about cohort analysis, so taking the data frame that you have and doing a very classic thing in clinical research, which is splitting into two cohorts and doing some mathematical analysis for each cohort. So let's get right into it. So at the end of last lesson, we cleaned our data frame, and I just want to show you two things that will make things easier on you. So remember, I did that typo last time. So if you want to remove a column from a data frame very simply, you can use this right here, df.drop, it's another function. And then in columns, you just in square brackets put which columns you want to drop. And then you set this variable in place to be true, which just means that it modifies the original database that you're working with. It's not going to create a new data frame. And so these variables here, this is kind of a good teaching point, columns and in place right here. These are variables that come with the function drop. So drop as a function, it needs something to fill columns and it needs something to fill in place. Sometimes there are defaults. So if I didn't have this in place true, I think it defaults to false. It defaults to making a new data frame. But a variable like columns, you need to pass in the column that you want to delete, which is intuitively makes sense. So let's run this, and then we could just take a look at our data frame, make sure it looks all good to go. Amazing. So this is, again, the end result. This is just the first 5 rows of the end result of our clean database, where we changed some values here and we expanded the blood pressure into systolic and diastolic columns. So after cleaning our database, we want to be able to access it whenever we want, right? We don't want to have to rerun code every time to be able to clean it. So very handy dandy function is to CSV. So we take the name of our data frame, and in this case it's df, and we do .to CSV, and then we just name what we want to call it. It'll save to whatever folder that this Python file is in. So I want to call it cleaned database, or cleaned data frame .csv. And then I'm going to run that, and it's saved in my documents folder because I'm in documents here. So now let's move to a new file. So I just made a new file. I called it video 3. You can call it whatever you want. And I want to get into this cohort analysis. And I want to show you just simple ways to do this so that you can just get your hands dirty and start. So we're going to import the same libraries again that we have been. Pandas, NumPy. And we're going to add something new. So we're going to say it's this library skippy.stats. Import. So we're saying from this library, I don't want to import the full library because it's huge. I'm picking specific things to import from just to save a little bit of memory and runtime on my computer. So from skippy.stats, import something called t-test independent, just like that, which is what it sounds like, an independent t-test function. And then chi-squared contingency. So these are both statistical functions that live inside this library, and I want to be able to access both of them so I can use it for my analysis. So I'm going to run that, and then let's do the first thing that you should do anytime you're starting a new Python file for data analysis, read in your data frame. So I'm going to call it df, and I'm going to do a handy dandy pd.read CSV, and I am going to pull in the cleaned database that I just saved. So cleaned data frame. Also, I'm using data frame database interchangeably, totally fine. Pull it in, and then let's just use, make sure we got everything. So great, 100 columns, what we were expecting. And now we have, 100 rows, and now we have 14 columns because we expanded our set a bit with the new blood pressure separate columns. Okay, and let's take an actual look at it. Okay, looks good to go. Okay, so now let's strategize what we want to do. I want to look at both continuous variables, so things that can be any number, and then I want to look at categorical variables, things like this binary variable that can only be 1 or 0, or gender or race. There are different ways to analyze both. So let's start with our continuous variable. And for now, I'm just going to do age as an example. So let's do a continuous variable analysis. Okay, so the first thing you might want to do is in your full database, you might just want some descriptive statistics. And so for a continuous variable like age, that often is the average with standard deviation, or it's often the median with quartiles, like the 25th or 75th percentile. So let's just do both so we can get a full picture. So if I want to get the mean, we did this last time, we do our data frame, we access the column, and then we can just use that function mean. And I can print it out so it stays there. And I can say, I can actually give it a label. So mean age, I think that should work. And I can give it a colon and a space. Okay, and then let's say I want to also do it for standard deviation. We know how to do that because we did it last time as well. Standard deviation, or it's not mean, just standard deviation is, and then, so if you put commas in print statements, it'll all stay on the same line. And now we want to access our age column and then do our standard deviation function, which is just .std. Okay, so we run that. Now we have the mean for the age and the standard deviation of our total data set. Super quickly too. And we can also do what I was mentioning, the median and the quartiles. So let's do it all in the same block of code. So we can print median age and then comma, and if I want to get the median, it's the exact same thing, just changing the function name. So calling the column, and then we're going to do dot median and those parentheses at the end. Okay, and there's our median age. And then if we want the quartiles, I'll show you this because this is a little bit new. So if we do 25th percentile, so we can use a function from the NumPy library, which remember I mentioned from last time is a library full of mathematical functions. So NP, and there's a handy dandy function called percentile. There's a function called percentile, and in this function, it takes in the list of numbers that you need and then the percentile that you want. So it'll calculate it based on those two things. It just has to know those two things. So what we want is our age column, and I'm going to use the function .toList just in case it needs it completely in a list form. So remember that .toList just takes this column age and turns it into a list. And then the percentile I want is 25. And so that's what it gives me. And then if I want to do the exact same thing for 75th percentile, I'm going to copy and paste this whole line and just change 25 to 75. Okay. And so this is all good descriptive statistics for a full data set of the age column. And so this process can be used for any other continuous variable. So in our case, in this data frame, the other continuous variables are heart rate, respiratory rate, height, weight, and then we have our systolic blood pressure and diastolic blood pressure. So we could repeat the same process on all of these. For the sake of time, I'm going to keep going just by using age to show you the rest of the stuff I want to do. So if we bring in a cohort analysis, so deciding what your cohort is definitely dependent on your research study. In this case, for this data frame, I'm going to decide our cohort is people who have COVID and people who don't. So we have this column, COVID status, and so the ones indicate COVID positive and the zeros indicate COVID negative. So we're going to use that. And so if I want to create two cohorts, then I can use my data frame to do that. So if I want COVID, I'll name it COVID. I want to create a new data frame. So COVID data frame is going to be all of the patients who are COVID positive. And the way to do this, so we call the original data frame, we do some square brackets, and then inside the square brackets, we call the data frame again, and we call the specific column that denotes our cohort, in our case, COVID status. And then so this is the COVID data frame, so I want COVID status to be equal to 1. So I do that double equal sign, because that's the comparator, equals, and then I set it equal to 1. And this line will give me a data frame. So it'll give me, the full set of columns, but only patients who are COVID positive. That is what this line is telling us. So if I run that, and then I take a look, COVID data frame, let's do .info. So there's now 47 entries, but I have still 14 columns. And then if I take a look at data frame, you can see it's all people with COVID. And then if I want to create my no COVID, so let's do no COVID data frame. It's the same thing, except now COVID status is 0. COVID status equals 0. So now I have 2 data frames, and I can run analysis on them separately. So if I wanted to get all of this information for just the COVID patients, I can recopy all of this. So age statistics for COVID patients. Paste it here, and instead of DF, I want to replace all the places it says DF with COVID DF, because this will only run on the COVID patients. And then I get all of my statistics here. And then I can, again, copy and paste this whole thing. Copy and paste is your friend in Python because it's very easy to change things. So I want to do all the age statistics for non-COVID patients. So I would just add no COVID DF instead of COVID DF. So I'm going to copy and paste. I paste. Here are the difference in statistics. And again, these can be run on any of the continuous variables. So you could do the same thing with heart rate, respiratory rate, the blood pressure, like we mentioned. Now, if we want to pull in a p-value generating statistic for continuous variables, that typically can be done with an independent t-test. Oftentimes I found in my cohort analysis research, this is the one that I'm using. So this is the one I decided to show in this video of how to use. So we imported it already, our function that will allow us to perform the independent t-test. And we are going to use it now. So the way you use it is t-test independent, and it's a function. So it takes in a couple things. It takes in the 2 sets of numbers that you are trying to compare. And it analyzes if there is a statistical difference between their average values. And so I want to do this for age. So there are several ways I could do this, but since we already created our different cohorts, different data frames for COVID patients and non-COVID patients, I can use those to my advantage. So I want to compare the age column of the COVID positive patients to the age column of the COVID negative patients. So I can use my COVID data frame, age, and I'm gonna do that function .toList, so it's in list form for this function to handle. And then no COVID data frame, age .toList. Okay, so what it gives us back is the statistic, and then what we really are focused on, so for research, the most relevant part is this p-value. So as we can see from this p-value, if you're using a threshold of 0.05, this tells us that it is age, the difference between average age in these 2 groups is not statistically significant. So again, this can be used for any of our continuous variables. If we want to perform, now if we want to move on and perform analysis on our categorical variables, there is a little bit of a different process. So let's take a look. If we look at our full data frame again, let's pick one to do this on. So if we do something like gender, we used a function in the last video called value counts. So .value counts gives you the number of patients who are of any of these category types, right, in this one categorical variable. So we have male, female, unknown, and we have the numbers here. If you want to get the percentages, so these are the raw numbers. If we want the percentages, we can use the same function, and we put 100 in here. And so the percentages are the same as the numbers here because our data frame is 100 patients long. Makes it pretty simple. If it was different, it'd be not just exactly the same as the raw values. But this is exactly what you put in a table. You put the raw values and then the percentages next to them for to just show the distribution of different categorical variables. The same thing can be done in this case for smoking status, which is categorical variable, race, and COVID status technically, but since COVID status is what we're using for our cohort, wouldn't quite be that. So then if we wanted to evaluate the spread of gender for COVID patients, so if we do gender distribution for COVID patients, we would use that data frame we created, COVID data frame, the data frame of just COVID patients, and we can get the gender column and we do value counts again. Value counts. And if we wanted the percentages, it's the same thing again. We put this and then just 100 in there to get the percentages. So now you can see they're not just the raw values because this data frame, the COVID data frame, is not 100 patients long. It was, I think, about 47. But again, these are what would go in your table, the 18, and then this is the percentage. And let's, for sake of practice, look at the gender distribution for non-COVID patients. So no COVID data frame, the gender column, calling the gender column, and then using value counts again. And we also want to see the percentages. Great. And again, whole process can be repeated on all of our categorical variables to get all the information we need for our tables. So the way to get a p-value for these types of variables is typically done with a chi-squared contingency test. And that is the second one that we imported here. And so we are going to use it. So chi-square contingency. This one is a bit more complicated than the independent t-test. So the function chi-square contingency, its contingency takes in a variable that should represent a contingency table. The way to get a contingency table, so before we run this, I'm going to comment this out, and sorry, any comments are using the hashtag. So the way to get a contingency table is we can use our pandas library, which is our data frame library. So if we want to build a contingency table, let's say contingency table, we can use a function called crosstab. And what it needs is the cohort values. So in our case, I'm determining that as COVID positive or COVID negative, and the categorical value. So whatever category you are trying to analyze, in our case right now, gender, those values as well. And so you'd pass in those two. So if we get our cohort values, let's start there. We're going to use the big data frame. We're not going to use our separate COVID and no COVID because the way this is done is it needs to combine all the data. So we're going to use our big data frame and our cohort values, like we determined, our COVID status. And then I'm going to do something called dot values to get the values of the COVID status column. And then this other function called dot flatten, just kind of take my word for it. It just helps things go into this table better. And so then I'm going to do, so that was for the cohort variables. So I'm actually going to write this in a different way to keep it simple. So we want a cohort values in here, and then we want our categorical values in here. So I'm going to call them variables. So I have to make these variables before. I just want to do this to keep it nice and clean. So the cohort values are our original data frame, the COVID status column, and then we want the values from it. So meaning either COVID positive, which is represented by a 1, COVID negative, which is represented by a 0, and then I'm just going to flatten them. And then for our categorical values, right now I'm working with gender. So I'm going to call that. And then same thing, I want the values and I want to flatten them. So let's run that. And then let's take a look at what this contingency table actually looks like. So this is a contingency table. It's essentially showing the values that are the cohort split. So COVID status 0, COVID status 1, and then of those, how many are female, male, and unknown. So it's combining the results of the two columns and showing how many numbers fit into each of these characteristics. So this is what needs to be passed into the chi-square contingency function. So let's get back to that. So we're going to take this and we're going to use it. So chi-square contingency, and now I can pass in my contingency table. And so this is what it gives me. These values, so the chi-square contingency table, it returns a chi-squared value, a p-value, the degrees of freedom, and expected values. All statistical components, you don't need to read too much into it. Really, for clinical research, the p-value is going to be the most important piece of information. So these are all the things that this function returns. I know this just by working with this function before. And so I can actually set these equal to the result of this. And then if what I really want to look at is the p, so I'm going to print the p-value, print that p-value. And I see that it is quite high. So again, it's not, there's no statistical significance in the difference of distribution of gender between COVID status being positive and COVID status being negative. So this is the p-value for the entire spread. And so this will give you the p-value that represents the significance and difference between distributions of gender between our two cohorts, meaning COVID positive and COVID negative. And again, this process can be used for any of the continuous variables. So we can even try it on smoking status or race in our case in this data frame. Thanks so much for watching.